All right. Is this thing on?
I think it is.
I can't see myself in there.
I could though.
I can't. Let's see. I'm looking. All right. 7-1 exponential functions. So today is a lot of review from what we did for like a full chapter in Algebra 1. All right. So think back. What is an exponential function? Well, it's essentially a function in which the variable is the exponent. Hence, exponential function. So we have two types of exponential functions. We have an exponential growth, where our growth factor is what we call it, is greater than 1. Or we have exponential decay, where our decay factor is going to be a fraction that's between 0 and 1. So with this one, it's just going to be a growth or a decay.
A growth.
The growth, because our b is greater than 1. So what does the growth look like? Well, again, if you don't remember what exponential equations look like, we can make a table. So if I plug in -2 for x, this is like 4 to the -2 power, which is equal to what?
1/4? No, wait.
1/16. Because remember, we can't have negative exponents, so that's like 1/4 squared, which is 1/16. So -2, 1/16, so it's really close to 0, but not quite 0. 4 to the -1 equals 1/4. Okay. 4 to the 0 power is 1. 4 to the first, 4 to the second,
16.
So again, we can plot these points. 1 up 4, 2 up 16 is probably up here somewhere. And notice our graph looks about like that. Big thing, okay, domain and range. I don't know if they ask you for it. Yeah, they do. Again, reminder, domain is our x values. Range is our y values. So what is our domain here?
All real numbers.
All real numbers. Okay, what is our range?
Oh, it has to be above 0.
Has to be above 0. So y is greater than 0. Okay, and again, if you want help with a table, right, we have our graphing calculators. So when I type this into our graphing calculator, remember we go to the y equals, so it would be like y equals 4 caret x. So we got to use that arrow, up arrow on our calculator when we graph it. So this is what an exponential growth looks like. It's going up. All right. So if we do another one, so we go y equals 1/2 to the x. Okay, so again, y equals 1/2 to the x. What's going to happen here? What kind of function do we have? Growth or decay?
Decay.
Decay. So again, I plug this in. 1/2 to the -2 power. That's like 2 squared, which is 4. So -2 up 4. 1/2 to the -1.
2.
So like 2 to the first, or 2. Okay, 1/2 to the 0.
1.
Okay, 1/2 to the first is 1/2, and 1/2 squared is 1/4. So again, difference here. Going down, right? Again, our domain,
Should be the same as last time.
yeah, it's actually going to be the same. Domain, all reals, because I can plug in anything in for x. Within our range, we're going to stay above 0. So what are some things that we can do to maybe affect this graph? Like move it up, move it down, move it sideways.
-1 or plus 1.
Maybe make it a little bit skinnier, maybe make it a little bit wider.
To make it wider, you'd have to times it by like another number in front of it.
Right, if we put another number in front of it, okay, that's gonna affect a little bit of where our slope is, okay, as far as how eventually it's gonna go up really fast in one direction.
And to make it go over or down, you have to
Whether
put
it's negative.
a plus or minus outside of the.
If we were to put a negative out in front of the parentheses, it's going to maybe add a number at the end,
Let's go up or down.
up or down, okay, if we
A number.
add or subtract a number or an exponent, where it's gonna shift it left or right, okay, so same thing that we've done in the past, as far as moving our exponential functions. Again, when you're doing this, if you wanna use your graphing calculator, be my guest, okay? Like that's probably the easiest way to do a lot of this, so you can save yourself some of these calculations, alright? Because again, the next step, they're gonna give you a few of these fairly simple functions, and then they're gonna say, okay, let's graph y equals 2. Actually, I'm gonna do a different one. 0.1 times 6 to the x minus 3. Okay, so again, when I make my table here, again, it's kind of a pain in the butt calculation, right? So I plug in -2, this is 0.1 times 6 to the -2 power minus 3. And it's like 0.1 times 1/36, because it's gonna be 1/6 squared minus 3. So again, look at how it's a pretty uncomfortable calculation. So, again, using your calculator, probably gonna be a little bit easier. So this is gonna be like 1/360
And then it's gonna be like
minus 3, so this is like -2.99, so almost -3, but not quite -3. You know, that's kind of important. Important thing. Next one, 0.1 times 6 to the -1. Again, 0.1 times 1/6 minus 3, so again, it's 1/60th minus 3, so again, -2.998 or whatever. So again, almost 3, but not quite 3. Okay, we plug in 0. Okay, I don't know why I did that. 6 to the 0, so we get 0.1 minus 3, so -2.9. So, you know, we're still kind of ways down there. Well, 0.1 times 6 is like 0.6 minus 3, so -2.4. So we're starting to come up a little bit.
36.
0.1 times 6 squared minus 3, so this is like 3.6 minus 3, so now we're up to 0.6. If we did third power, 6 cubed is 216, I believe. So this is gonna be like 21.6 minus 3, so now all of a sudden over here at 3, we're up at 18. So again, it's gonna stay really flat for a little bit, and then it's really gonna take off. So again, what would we have here, growth or decay?
Growth.
Growth, because again, our b is greater than 1, okay? Our domain and range,
Domain's gonna be all real numbers.
domain still all reals, which should be the case today when you're doing domain, exponential functions should be all real numbers. Our range, however, this time it's gonna be different.
Y is greater than -3.
Y is greater than -3. It's gonna get really, really close to -3, but it's never gonna get to -3, per se. It's always gonna be -2.99 with a whole bunch of nines behind it. Alright? So, again, a large part of this, like I said, I want you to graph this on your own. I would even like to see the table, but I would use your calculator for the table. Does everybody remember how to get to the table in your calculator?
Second.
Reminder, again, first step, plug into our function in the y equals button. Open your calculator. So y equals button. okay, and then we can go second window. Okay, then you can set your table change, like it has table start. And table change, so like table start, you could do -5 if you want, and then just go by ones. And then to see your table, then you go second graph, and that should show you your table where you can arrow up, arrow down, to see what those numbers are. And then if you want the graph, remember you can change your window, then you can look at the graph, and you can see where it's at, going up, down, what's gonna be our domain, what's gonna be our range, etc., etc. Okay. Okay, so where is this used? Okay, where do we use exponential functions? One of the main places, interest. All right, interest with loans, interest where you have a savings account or an investment where you're gaining interest, so making some money. Exponential functions are used to project those values. So if we have an exponential growth, like our interest is growing, population growth or population decrease is another place where we use this. A lot of times we go y, I shouldn't say that, well, we can use y equals a, okay, and then instead of b, we're gonna go 1 plus r raised to our x. Now our y is our final value. Okay, our x is usually our time, typically in years. And then our r is our percent increase. Okay, and again, this is a growth. If we have a decay, our equation is going to look like,
You go for
Mason, are you paying attention?
Yes.
Okay, so our decay, what do you suppose is going to be different about our decay?
It's gonna be 1 minus r.
This is going to be 1 minus r. The one thing I forgot in this top one, what does a represent? Anybody know?
Your starting number.
That's going to be our starting value. All right, so if our if I started with an initial investment of $1,000, that's where that number would go. Okay. Again, decay, all of these things are the exact same. Again, it's just back as 1 minus r. Okay. So an example of where we would use this, I'll say, let's use the school population example. School population in 2012 in Rock County was, I don't know, we'll call it 190 students. Population has increased by 2% each year. What will the school population be in 2025? So first of all, is this going to be a growth or decay?
Growth.
Growth, because the population is increasing. So we're going to use this equation. So again, we're looking for our final value in 2025. So y equals, okay, our a, so what's our initial value? 190 times 1 plus r, what is our r?
2%.
which is what?
0.2.
0.02, so this is gonna be like 1 plus 0.02, or 1.02. Now what's our time gonna be?
5. Oh wait.
3. Oh wait, no.
13, because again, our starting year was 2012, 2025 is 13 years after that, alright? So now, this is a type in the calculator, 190 times 1.02 raised to the 13th power, and our projected population, and this is K through 12, will be what in 2025, assuming this trend is continuing. $245, okay? Okay, and I think that's about where we are this year, for being honest. So, again, that could be true because maybe we flatten out, alright? What could happen that would maybe change that? What would maybe make it grow faster?
People like transferring in.
People moving in, right? Okay, maybe something happens over at one of the neighboring school districts that pushes people out, right? Maybe, again, not saying this is gonna happen, so don't go out and say, Mr. McCreary said, you know, maybe Spring View closes, right, whatever, not enough kids, so then some of those kids come here. Okay, again, completely hypothetical, what would make it go down? Potentially.
Something bad happens here.
Okay, yeah, okay, maybe, you know, cattle prices go way down, so that forces some people to sell land, cut ties and, you know, move on elsewhere or whatever, so, like I say, you never know, that's why these are projections, they're never, accurate, cause there's always a lot of variables that can affect, you know, these types of things, but this is where, again, a lot of, exponential functions are used, so, like I said, if you wanna do page, what is it, 12 through 30 evens, if you wanna do the odds, I don't really care. Yeah, if you wanna do page 456, 13 through 29 odds,